Hello. In this video, we'll be covering concepts from the course Chemistry 1412, also known as General Chemistry 2. I'm going to go ahead and share my screen for you and open up a PowerPoint presentation showing the concept that we'll be covering today. The concept that we're covering today is called half reactions. Half reactions are a method of balancing redox reactions. This method divides a redox reaction into the oxidation and reduction half reactions. There are going to be 4 steps for acidic solutions and 5 steps for basic solutions. If you don't quite remember what a redox reaction is, don't worry too much. I'm going to be showing you a quick video on balancing an acidic solution and a basic solution. And in that video, they will give you a brief overview of what a redox reaction is. So in an acidic solution, like I said, there is 4 steps. Within step 2, there are 4 different parts. So if you want, you can just number all of them in pretty much whatever order you want. Or so, for example, you can either have 2 and then 4 subparts, or you can just number each of them. So the first step is to divide your reaction into 2 half reactions. So you'll have 1 oxidation and 1 reduction half reaction. You're then going to balance your elements and charges. So you have to do it in this specific order. So the first step is going to balance your elements other than oxygen and hydrogen. So for example, if in your reaction you have chlorine, you would just be balancing those chlorine elements. You'll then balance your oxygens by adding water. After you balance your oxygens, you're going to balance your hydrogens by adding H+ ions. As soon as all of your elements are balanced, you're then going to balance the charges by adding electrons. Keep in mind that electrons are negative when you're doing this step. After you balance your charges, you will then multiply one or both half reactions by an integer to make the electrons match. What this is saying is in part 4 of step 2, after you have added your electrons, say for instance your first half reaction only has 1 electron while your second half reaction has 2. You would have to multiply your first half reaction by 2 to allow your electrons to be equal. After you do that step, you will then add the 2 half reactions together and simplify if need be. I'm going to go ahead and show you a video. It is from Khan Academy. It's a great resource to use. And in this video, they'll be balancing.
Our goal is to balance this redox reaction in acid. And before we get into the steps, let's talk about the fact that this is a redox reaction by assigning some oxidation states. And so we start over here with the dichromate anion, and we know that oxygen has an oxidation state of -2. We have 7 oxygens, so -2 times 7 gives me -14 as our total here. We know that the total for the entire anion has to equal -2, which is the charge on the dichromate anion. Therefore, we must have +12 for all of our chromiums here. So +12 and -14 give us -2. Since we have 2 chromiums, each one must be +6, and so that's the oxidation state for chromium here. We go over here to the chloride anion, right? So the charge is -1, so our oxidation state is -1. Chromium ion over here, so +3, and then finally chlorine over here, so oxidation state of 0. So if we look at chlorine, chlorine went from an oxidation state of -1 to an oxidation state of 0. That's an increase in the oxidation state. Therefore, chlorine was oxidized here. Look at chromium. Chromium went from +6 to +3. That's a decrease in the oxidation state, or a reduction in the oxidation state. Therefore, chromium was reduced. So this is a redox reaction because something is oxidized and something is reduced. In terms of balancing it, our first step is to write the different half reactions. So we're going to break those into an oxidation half reaction and a reduction half reaction. So let's go ahead and get some space down here, and let's go ahead and write our half reactions. And so we had the chloride anion, right, going to chlorine like that, and we we said that this was our oxidation half reaction. So I'll put that way over here on the right. So that's our oxidation. Our reduction half reaction involved chromium, right? So we had the chromate anion here, so Cr2O7 2 minus, right, going to chromium 3 plus like that. So this is our reduction half reaction. So that's step one. Write the different half reactions. Step two, balance the atoms other than oxygen and hydrogen. And so if we look at our first half reaction, right, chlorine, we have one chlorine on the left and two chlorines on the right. So we need to balance it by putting a 2 over here on the left like that. We go down here to the reduction half reaction, and we have two chromiums on the left and only one on the right. And so we have to put a 2 right here to balance it. So step 2 is done. Step 3, balance the oxygens by adding water. So if I look at my oxidation half reaction, right, there are no oxygens, so I don't need to worry about doing anything to this half reaction at the moment. I go down to the reduction half reaction, and I do have to balance my oxygens, right? So if I go over here, and I can see that I have 7 oxygens on the left side and none on the right. And so I need to do that by adding water. And since I have 7 oxygens on the left, I need 7 oxygens on the right. So I'm going to go ahead and add 7 water molecules, and that now gives me 7 oxygens on the right of my half reaction. So that's the step 3 right here. Step 4, balance the hydrogens by adding some protons. So let me go ahead and I'll use red for this. So step 4, balance the hydrogens by adding protons here. Once again, the oxidation half reaction, we don't have to do anything because we don't have to balance oxygen or hydrogen here. But again, we go down to our reduction half reaction, and we have the oxygens balanced by adding water. But by adding water, now we have some hydrogens on the right side. So we can see we have a total of 14 hydrogens on the right side. So 7 times 2, and so we're going to balance that by adding protons, and so we need to add protons to the left side of our half reaction, so we need to add 14. So 7 times 2 is 14, so we go ahead and add 14H plus to the left side of our half reaction. So step 4 is done. Step 5, balance the charges by adding electrons. So let's get some more space here first of all. Okay, so we're going to balance the charges by adding electrons. So first let's analyze what kinds of charges that we have here. So we'll start with the top oxidation half reaction. So we have the chloride anion, right, which is a -1 charge, and we have 2 of them. Right, so we have 2 negative charges. So there's 2 negative charges. Notice these are not oxidation states, so that's what gets people confused sometimes. These are charges. Over here on the right, we have no charges, right? So that's a neutral chlorine molecule here. So we have 2 negative charges on the left and 0 for a charge on the right. So we need to figure out how to balance those charges by adding electrons. And so it makes sense that we would have to add 2 electrons to the right over here, because that now gives us a total charge of -2 on the right. So that's one way to think about it, just getting these numbers equal here, this -2 right here and this -2. Another way to do it would be, of course, the electrons have to go on the right side, because this is the oxidation half reaction. And one of the ways to remember that, right, Leo the lion, right, so loss of electrons is oxidation. And so if you're losing electrons, they must go on the product side of your half reaction. And so our top half reaction, our oxidation half reaction, is now balanced. Let's go down to our reduction half reaction, right? So Leo the lion goes grr, so gain of electrons is reduction. So we already know we're going to have to add electrons to the reactant side of this half reaction. But let's see if we can figure out how many electrons we're going to need to use. So we have 14 positive charges from the protons, and then we have 2 negative charges from the dichromate anion here. So we have 14 positive charges and 2 negative charges, which gives us a total of 12 positive charges on the left side. On the right side, we have a chromium ion, right? So this is a charge of 3+, and I have 2 of them. So 2 times +3 gives me +6. So I have +6 on the right side of my half reaction. So I have +12 on the left, +6 on the right. I need to add some electrons to balance out that charge. I already know I'm going to add them to the reactant side, right? I know that from Leo the line goes grr. Or I can just think about the fact that if I have 12 positive charges, I would need to add 6 negative charges to get me to a total charge of +6. So I need to add 6 electrons electrons to the left side over here. So I'm going to go plus 6 electrons like that. And now we have the charges balanced. And so this step is done. So step 5 is done. We move on to step 6. So make the number of electrons equal. So what does that mean? Well, let's focus in here on the electrons that we just added to our half reactions, right? So if I go back up to here, all right, we added 2 electrons to the oxidation half reaction, and we had 6 for the reduction half reaction. But we know that that number has to be the exact same number because the electrons that are lost, right, from our oxidation half reaction are the exact same electrons that are gained in our reduction half reaction. So that is why we have to make these electrons equal in terms of the number. And so the way to do that would, of course, be to multiply my first half reaction by 3, because if I multiply my first half reaction by 3, that would give me a total of 6 electrons, which is what we're looking for, making the number of electrons equal. So let's go ahead and do that. I'm going to rewrite our first half reaction. I'm going to multiply everything in our half reaction through by 3, so everything in parentheses. So if I take 3 and multiply that by 2 chloride anions, I would, of course, get 6, right? So we have 6 chloride anions like that. And then the 3 would go in front of the chlorine, so I have 3Cl2, and then 3 times 2 electrons, right, gives me 6 electrons like that. Okay, let's go ahead and rewrite our reduction half reaction because we have a lot of stuff going on here. So I'm just going to rewrite exactly what we have. 6 electrons plus 14 protons. 14 protons here plus the dichromate anion like that. Right? And then I have 2 chromium ions and 7 waters. Okay, so now I have my 2 half reactions. I've made the number of electrons equal, and we're ready for the last step. We just take our 2 half reactions, and we're going to add them back together, and that's going to give us our overall balanced redox reaction. So let's go ahead and we'll go ahead and say we did this, and let's go ahead and get some more room here so we can add those 2 half reactions. All right, so all I'm going to do is just take everything on the reactant side, right? Take everything on the reactant side here, right, and add that together. So let's go ahead and just rewrite everything on our reactant side with 6Cl minus, right, and then 6 electrons, 14 protons, right? We have the dichromate anion here. And then I'm going to take everything on my product side, right? So I'm going to take all of this stuff right here, right, and put that on my product side. So I have 3Cl2 plus 6 electrons, right, plus 2 chromium ions plus 7 water molecules like that. And so now it's just a little bit easier, I find, for students to see that your electrons are going to cancel, right? You have these 6 electrons on the reactant side, you have these 6 electrons on the product side, so you can go ahead and take those out. And we're left with our final answer, right? So you can go ahead and rewrite it if you want to make it look better. We have 6Cl minus plus 14H plus Cr2O72 minus yields 3Cl2 plus 2Cr3 plus 7H2O. And this should be our final answer. So I always like to box my final answer, so it just makes it easier for your instructor to grade. And the nice thing about redox reactions is when you're finished, you can always check yourself because you know that you need to balance both the atoms and the charge. So let's go ahead and check that real fast. Let's first start with chlorine, right? So we have 6 chlorines on the left. Then over here on the right, we have 3 times 2, which is 6. So chlorine's balanced. Hydrogen, we have 14 on the left, and then 7 times 2 gives us 14 on the right. The chromiums, we have 2 on the left, and then over here we have 2 on the right. Oxygens, 7 oxygens on the left, and then over here, right, this 7 applies to this oxygen, and so the atoms are balanced properly. Let's next check charge, because you have to have the correct charge. We have 6 negatives, right? So 6 negative charges. I'm going to put minus 6 here. And then I have 14 positives, right? So I have positive 14. And then I have negative 2 right here, right? So when I add all those up, I get a total of plus 6 on the left side, right? So you know, 14 minus 8. Over here on the right side, the only charge is this chromium ion. It's 3 plus, and I have 2 of them. So 2 times 3 gives me plus 6. And so the charge balances as well. And so you know this is the correct answer. It balances both in terms of atoms and in terms of charge.
All right. Give me 1 second. And we'll go back to our PowerPoint presentation. So now that you have viewed one completely worked, we're going to work 2 examples of our own. So right up at top, we have our redox reaction. So we have Cr2O72 minus plus I minus yields Cr3 plus I2. The first step is going to be to divide our redox reaction into 2 half reactions, one being oxidation and one being reduction. Just as a tip, I think it makes it a lot easier is if you drop your states, so the aqueous or solid states, until you get to the very end, and then you can always add them back in later. So when we divide into our 2 half reactions, we get Cr2O72 minus yields Cr3 plus, and I minus yielding I2. We're then going to move on to step 2. So part A is going to be to balance the non-oxygen, non-hydrogen elements. So in our first half reaction, the Cr is going to be our non-oxygen, non-hydrogen element that we need to balance. On the left side of the first half reaction, we have 2 Crs, so we need to add the 2 onto the right side. On the second half reaction, on the left side, it originally only had 1 I, while on the right side it had 2, so we had to add a 2 in front of the left side. We're then going to move on to balancing our oxygens by adding water. In our first half reaction, we have 7 oxygen. So we need to add 7 water to be able to get the same amount of oxygen on the right side as we did the left. Our second half reaction has no oxygen, so it's simply going to remain the same. The next part is going to be to balance your hydrogens by adding H+. So because we added water to our right side, we then need to add H pluses to the left side to balance those hydrogens out. Since we added 7 water, we now have 14 hydrogens on the right side, so we need to add 14 H pluses to our left side. Our second half reaction has no hydrogen, so it's simply going to remain the same. We then get to the part where we're balancing the charges by adding electrons. So make sure that you're really paying attention to the coefficients, because those coefficients will apply to the charges. So by adding 6 electrons to our left side, we're able to get our half reaction to balance to where we have a positive 6 charge on both sides. We know that because we have plus 14 minus 2, so that gives us a positive 12 on the left. And then on the right side, we have a plus 6. And because we're adding electrons and they're negative, we need to add them to the left side to get our positive 12 down to positive 6. So we can add 6 electrons to allow that to happen. For the second half reaction, we have 2 minus on the left, but we had a 0 on the right. So we need to add 2 electrons to our right side to get both sides to have a charge of negative 2. Now we need to allow our electrons that we just added to be equal to each other. So in our first half reaction, we had 6 electrons. In our second, we had 2. So if we multiply our second half reaction by 3, and make sure that you apply it to each of the items within your half reaction, we can allow our electrons to balance. So you will get 6I minus yields 3I2 plus 6E minus. We then can add our half reactions together. So in the video, they added everything into one reaction and then they canceled out the items such as the electrons. I do it slightly different. I like to cancel it out before I add everything together. However, you can do whatever makes you feel more comfortable. So I have my two half reactions, and the electrons are the only items that can cancel out. So I cancel my electrons out, and I can get my final answer when I add everything back together. So I'll get 6I minus plus 14H plus Cr2O72 minus yields 3I2 plus 2Cr3 plus 7H2O. And the only thing that is really new in our new redox reaction is the H plus ions, so that will become aqueous, and then our water, which will be liquid. We're now going to do a second acidic solution or reaction before we move on to our basics. So we have HNO2 yields NO plus NO2. This one is kind of tricky. It's something that a lot of students haven't seen. So in this example, we only have one compound on our left side, but we have two on the right. What you're simply going to do is use that compound or reactant twice. So you're going to get HNO2 yields NO and HNO2 yields NO2. We're then going to balance our non-hydrogen, non-oxygen elements. However, what you'll notice is that the nitrogens are already balanced in both half reactions, so they will stay the same. You're then going to balance your oxygens by adding water. In our first half reaction, we have two oxygens on the left side, but we only have one on the right. So we're going to add one water molecule to our right side to allow our oxygens to balance. In our second half reaction, both sides have two oxygens, so it will stay the same. After our oxygens are balanced, we're going to balance our hydrogens by adding H+. So we only have one hydrogen on the left side, but we have two because we added that water molecule on the right side. So we need to add one hydrogen ion to our left side to allow our hydrogens to balance. For the second half reaction, we have one hydrogen on the left, but we don't have any on the right, so we need to add a hydrogen ion to our right side. You're then going to balance your charges by adding electrons. So on the left side, because we added that hydrogen ion, we have a positive 1 charge. On the right side, it had a charge of 0. So by adding an electron to our left side, it will allow both sides of the half reaction to have a charge of 0. We'll do the exact same thing to our second half reaction. On the left side of our second half reaction, we have a charge of 0, but because we added that hydrogen to the right side in our previous step, we now have a positive 1 charge. So by adding an electron, we can get rid of that positive charge and allow both sides to be equal to 0. Step 3, so as you can notice that our electrons in both half reactions are already equal. So if your electrons are already equal at step 3, you simply can skip this step and move on to your fourth step, which is going to be to add your two half reactions together. So just like we did before, we're going to cancel out the items that are similar. So in our first half reaction, we have one electron and we have an H+ ion. We have the same thing in our second half reaction, so those two can be canceled out. After we cancel them out, we get our final answer of 2HNO2 yields NO2 plus NO plus H2O. And now we're going to move on to basic solutions. So just like I said before, your basic solution is going to have one more step other than the steps that we see 1 through 4 right here. You'll notice that they're the exact same as the acidic solution. So you're going to go through step 1 through 4 just like you did in acidic solutions, but you're going to add this 5th step for a basic solution, which is going to be to add your OH minus for every H plus that you have. And this is going to be, because we have a basic solution, we need to neutralize the H plus ions. So I'm going to go ahead and show you another Khan Academy video, this time balancing basic solutions.
In the previous video, we saw how to balance redox reactions in acidic solution. In this video, we're going to balance a redox reaction in basic solution. And these are a little bit harder, but we're going to approach it the same way that we balanced the reactions in the acidic solution. So we're going to, once again, step 4, add some protons here. And we're going to go ahead and add the half reactions together, but after we do that, we're actually going to add some hydroxide anions in here as well. Since this takes place in basic solution, the hydroxide ions are necessary to neutralize the protons that we added in step 4. And so let's start off by starting with oxidation states, right? Just like we did in the previous video. So if I start with the hypochlorite anion here, I know that oxygen has an oxidation state of -2. I know the total has to equal -1 here, so that means that chlorine must have an oxidation state of +1. +1 and -2 give you -1. If I go to this chromium compound over here, the easiest way to approach it is to remember that the hydroxide anion has a charge of -1, and you have 4 of them, giving you a total of -4. In terms of oxidation states, the total has to add up to equal -1 here, the charge on the ion. Therefore, chromium must have an oxidation state of +3. +3 and -4 give you -1. So chromium's oxidation state is +3 here. Move over here to the right to the chromate anion. So oxygen is -2. I have 4 of them for a total of -8. I need to get a total of -2, the charge on the ion. And so for an oxidation state for chromium, it would be +6, because +6 and -8 give you -2. So chromium's oxidation state is +6 here. And then finally, for the chloride anion, -1 charge, therefore an oxidation state of -1. In terms of what is being oxidized and what is being reduced, you need to look for an increase in the oxidation state for oxidation. So going from an oxidation state of +3 to an oxidation state of +6 for chromium means chromium was oxidized. And if we look at chlorine, right, it's going from an oxidation state of +1 all the way over here to an oxidation state of -1. That's a decrease in the oxidation state, or reduction in the oxidation state. So chlorine is being reduced. And so we know that something is being oxidized and something is being reduced. And so we can go ahead and do step 1 now. We're going to write our half reaction. So 1 oxidation half reaction and 1 reduction half reaction. This time, let's go ahead and write the reduction half reaction first. It doesn't really matter which one you do. So we'll go ahead and write the one using chlorine, since chlorine was reduced here. So the hypochlorite anion going to the chloride anion here. So this is the reduction half reaction. The oxidation half reaction is the one that involved chromium. So we had this chromium compound, CrOH4, with a negative charge, right, going to chromate, CrO4 2-. So this is our oxidation half reaction. So let's go to step 2, balance the atoms other than oxygen and hydrogen. So the atoms other than oxygen and hydrogen. So for the reduction half reaction, that applies to chlorine. We have 1 chlorine on the left, and we have 1 on the right. So chlorine's balanced. In the oxidation half reaction, that applies to chromium, right? So 1 chromium on the left and 1 chromium on the right. So in this case, step 2 is already done for us. But always be careful, because sometimes you actually have to balance these atoms, and it will affect your final answer. So let's go to step 3, balance the oxygens by adding water. So if we look at our reduction half reaction, we can see there's 1 oxygen on the left side, and we have no oxygens on the right side. So we need to add 1 water molecule to the product side of our reduction half reaction. Now we have 1 oxygen on the right and 1 oxygen on the left, and so oxygen is balanced for our reduction half reaction. Let's look at our oxidation half reaction. Remember, this 4 here applies to everything in the parentheses, so we have 4 oxygens on the left, and we have 4 oxygens on the right, and so oxygen is already balanced. Next, we go to step 4, balance the hydrogens by adding protons. So if I look at my reduction half reaction, we added a water molecule, right, and that introduced 2 hydrogens on the right side of my half reaction. So therefore, I need 2 hydrogens on the left side because right now I don't have any, and I'm going to balance them by adding them in the form of protons. So I have to add 2 protons to the left side of my reduction half reaction, and now I have 2 hydrogens on the left and 2 hydrogens on the right. For my oxidation half reaction, remember this 4 applies to the hydrogen as well, so I have 4 hydrogens on the left and none on the right side of my oxidation half reaction. So I need 4 on the right. I'm going to add those in the form of protons, so 4H plus on the right side. Next, we're going to add electrons to balance charge. So step 5, we need to analyze the total charges on both sides of my half reaction. So let's look at the reduction half reaction first. I have 2 protons, right? So that's 2 positive charges on the left side here. And I also have a negative charge on the hypochlorite anion here. So I have 2 positive charges and 1 negative charge. So of course that's a total of +1. And I have a habit of writing my charges like I have how I write my oxidation states. So just remember that these are charges, not oxidation states. And a total of +1 on the left side, and on the right side, right, I have 1 negative charge on the chloride anion, and that's it in terms of charges. And so I have a -1 charge on the right side here. So I need to get those charges to be equal, and I can only get that by adding electrons, which are, of course, negatively charged. So if I want to get both sides of my reduction half reaction equal, the only thing I could do is add 2 electrons to the left side right here, because that gives me 2 more negative charges. So that takes this +1 to a -1. So now I have a total of -1 charge on the left side of my half reaction. And that, of course, is now equal to the -1 on the right side of my half reaction. So I have balanced the charges by adding electrons. Let's do the oxidation half reaction now. So I have only one of these ions, so I have a -1 charge on the left side. On the right side, I have 1 chromate, but each chromate has 2 negative charges, like that. And then I also have 4 positive charges for my protons. So -2 plus 4 gives me a total of +2. So I have +2 on the right side and -1 on the left side. So once again, my goal is to balance those charges by adding electrons only. And if I add 3 electrons to the right side of this half reaction, right, I would change this total charge from a +2 to a -1. And so now I have -1 on the right, and I have -1 on the left. And so my charges are balanced. Another way to think about where those electrons go, right, is to remember that Leo the lion goes grr, right? So oxidation, Leo, loss of electrons is oxidation. So that's why you have to show your electrons on your oxidation half reaction being lost or given off on the product side, if you will. And then Leo the lion goes grr, so gain of electrons is reduction. So you would have to show the electrons for your reduction half reaction being on your reactant side of your half reaction because they're being gained here. So that's another way just to double check yourself or think about it. So we're on to step 6 now. Make the number of electrons equal. So for step 6, make the number of electrons equal. So the reason you have to do that is because the electrons that are being lost in the oxidation half reaction are the exact same electrons that are being gained in the reduction half reaction. So we had 3 electrons being lost, but only 2 electrons being gained. That doesn't make any sense, right? They're the same electrons, they should be the same number. And so we need to make those number of electrons equal. And the way to do that, of course, is to think about lowest common denominator. So we have a 2 and a 3. So we can make those 6 electrons. So we need to figure out a way to make both of our half reactions have 6 electrons. And we can do that by multiplying our first half reaction by a factor of 3 and multiplying our second half reaction by a factor of 2. And that will give us equal numbers of electrons. Let's go ahead and do that math here. So let's go ahead and take 3 times 2 electrons, right? That gives me 6 electrons. And then 3 times 2 protons, right, gives me 6 protons. 3 times the 1, the coefficient in front of the hypochlorite anion, gives me 3ClO minus. The 3 times the 1 in front of the chloride anion gives me 3Cl minus. And then finally, there's a 1 in front of the water as a coefficient as well. So 3 times 1 gives me 3 waters. So let's go ahead and do the oxidation half reaction now. Let's get some more room here. So I take the 2, I multiply it through this coefficient of 1 in front of here, in front of this ion. So now I would have 2Cr parentheses OH4 minus. The 2 applies to the 1 coefficient in front of the chromate as well, right? So I would have 2CrO42 minus. The 2 applies, right, 2 times 4 gives me 8 protons, so I have 8 protons here. And then finally 2 times the 3 electrons gives me those 6 electrons. And so now we have 6 electrons for my reduction half reaction and 6 electrons for my oxidation half reaction. Next, we're going to add our half reactions together. So once again, we're still pretending like we are in acid here. So let's go ahead and add our half reactions together. We're going to take all of our reactants, right, and put them on one side. So let's go ahead and do that first. So we have 6 electrons plus 6 protons plus 3ClO minus plus 2Cr parentheses OH4 minus. And so on the right side, so we take all of this, right, and we add it all together for our product side. Right, so let's see what we have. We have 3Cl minus plus 3H2O plus 2CrO42 minus plus 8H plus 6 electrons. So finally, all right, now that we've written that out, I think it's easier to see that you have 6 electrons on the left and 6 electrons on the right, so you can cancel those out. You also have some protons on both sides, right? You have 6 protons here and 8 protons here, so you could cancel out these 6 protons, and you could make this 2 protons on the right side. So let's go ahead and rewrite what we have once again. So let's see what we have now. Now that we've simplified a little bit, we have 3ClO minus plus 2Cr parentheses OH4 minus yields 3Cl minus plus 2H2O, 3H2O plus 2CrO42 minus plus 2H plus. All right, so now we have to remember that this reaction was actually done in base. Right, so we're going to add in some hydroxide anions to neutralize the protons. So if we look at the number of protons we have, right, we have 2 protons over here on the right. So we need to add 2 hydroxide anions. So we're going to add 2 hydroxide anions to neutralize those protons. And since this is a balanced equation, what we do to the right side, we have to do to the left side as well. So since I added 2 hydroxides to the right, I add in 2 hydroxides to the left. Now let's think about what adding those hydroxides to those protons will do, right? So they will neutralize each other. If you take H plus and OH minus, you will get H2O. And so we're going to get water molecules, and we're going to get 2 of them since we're neutralizing 2 protons with 2 hydroxide anions. And so actually on the right side, we're going to get 2 H2Os here, so 2 water molecules on the right side. So let's go ahead and write the final answer here, including everything that we've done. So on the left side, we have 3ClO minus plus 2Cr parentheses OH4 minus, and now we added in those 2 hydroxides, right? So plus 2OH minus, and then on the right side we had 3Cl minus plus, well, over here we have 3 waters, and we just made 2 more, and so we really have a total of 5. So 5H2O, and then once again we have the 2 chromates over here, so 2CrO4 2 minus. And that should take care of everything. So we can go ahead and box our final answer. So we got there. It took us a long time, but we have our final answer. And remember, you can always check your final answer in terms of number of atoms and charge. So both atoms and charge should balance. And so you can go ahead and check this one on your own, just like I showed you how to do it in the previous video.
All right. Go ahead and pull our PowerPoint back up, and we'll work through 2 of our own examples. So our first example is Br2 yields Br O3 minus plus Br minus. So just like we said in our acidic example, the Br2 is going to be used twice. So you have Br2 yields BrO3 minus, and Br2 yields Br minus as our two half reactions. We're then going to balance our non-oxygen, non-hydrogen elements. So our non-oxygen, non-hydrogen element is going to be the Br. So we have, in both half reactions, we have two Brs on our left side, and we only had one on the right. So we need to add a 2 in front of both of our products for both half reactions. We're then going to balance our oxygens by adding water. So in our first half reaction, we have 6 oxygen, because we have a 2 here as our coefficient and 3 down below. So we have 6 oxygen on our right side, so we need to add 6 water molecules on our left. Our second half reaction has no oxygen, so we will just keep it the same. We then are going to balance our hydrogens by adding H+ ions. So because we added our water molecules, we now have 12 hydrogens on our left side, so we need to add 12 hydrogens on our right side. Our second half reaction doesn't have any hydrogens, so it's just going to remain the same. We're then going to balance our charges by adding electrons. So on the left side of our first half reaction, we have a charge of 0. On the right side, we have a charge of, right here we have -2, we have +12 here, so that gives us a +10 on our right side. So to get them to balance, we have to add 10 electrons to that right side to allow both sides to be equal to 0. For the second half reaction, we had a charge of 0 on the left, but -2 on the right. So we need to add 2 electrons to our left side to allow both sides to be equal to -2. We're then going to multiply to make our electrons equal. In our first half reaction, we had 10 electrons. In our second, we only had 2. So by multiplying our second half reaction by 5, we can allow those electrons to be equal to each other. When we multiply by 5, we're going to get 10 electrons plus 5 Br2 yields 10 Br minus. We can then cancel out our like items so that we can add our two half reactions together. So the only like items are going to be those electrons. Remember that in the video they show you to add them together and then cancel out, or you can cancel them out then add together. Really, it's up to you, whatever makes you feel more comfortable. They'll both give you the exact same answer. Once we add them together, we get 6H2O plus 6Br2 yields 2Br3 minus plus 12H plus 10Br minus. What you'll notice is that each of the coefficients can be simplified by a factor of 2. So we're going to divide each of those numbers by 2 to simplify it. We'll get 3H2O plus 3Br2 yields BrO3 minus plus 6H plus 5Br minus. We can now use this equation to move on to our step 5, which we do for only basic solutions. And that is going to be to add our OH minuses for every H plus that we have. So in our reaction, we have 6H plus ions, which means we need to add 6 OH minuses to both sides of the reaction. And just as a reminder, when we add our OH minus and our H plus, we form water. So the OH minus and the H plus will become 6 water molecules on that right side. So we'll get 6 OH minus plus 3 H2O plus 3 Br2 yields BrO3 minus plus 6 H2O plus 5 Br minus. However, that is not our final answer. We do need to simplify. So you'll notice that there are water molecules on both sides of our reaction. So we can cancel all 3 water molecules on the left side and 3 out of the 6 water molecules on the right side. So when we rewrite our final answer, we're going to get 6OH minus plus 3Br2 yields BrO3 minus plus 3H2O plus 5Br minus. And that would be our final answer for this equation, or for this problem. And just like in the video, you can always double check to make sure your charges and atoms are equal to each other. Now we're going to do one more basic solution example. So we have I minus plus OCl minus yields I2 plus Cl minus plus H2O. This one's different from any that you've seen before as well. You'll notice that there are 3 products. However, we're doing half reactions for redox, so we only really care about the oxidation and reduction reactants and products for our example. So we're not going to worry about this water that is attached as a product. It's not going to be seen in your 2 half reactions. You're simply going to see what is being oxidized and what is being reduced. So you have I minus yields I2 and OCl minus yields Cl minus. We're then going to balance our non-oxygen, non-hydrogen elements. So in our first half reaction, our I is not balanced. We need to add a 2 in front of our left side to allow them to be equal to each other. In our second half reaction, we have 1 chlorine on both sides, so it is already balanced. We're then going to balance our oxygens by adding water. Our first half reaction has no oxygen, so it will remain the same. In our second half reaction, we had 1 oxygen on our left side, which means we need to add 1 oxygen to our right side to allow them to be equal. After we have our oxygens balanced, we can now balance our hydrogens by adding H plus ions. When we added the water molecule in our second half reaction, we had 2 hydrogens on our right side, which means we needed to add 2 hydrogen ions to our left side to balance out. Once your hydrogens are balanced, you can begin to balance your charges by adding electrons. On our first half reaction, we have a charge of -2 on our left side and 0 on the right, which means we need to add 2 electrons to our right side to allow each side to have a charge of -2. For our second half reaction, we see that we have +2 and -1, which gives us a +1 on our left side and a -1 charge on our right, which means we need to add 2 electrons to allow both sides to have a charge of -1. After your charges are balanced, we need to make our electrons balanced. So you notice that we have 2 electrons on both sides, which means that they're already balanced, so step 3 can be skipped for this example. We're then going to cancel out our like items so that we can add them together. The only thing that is similar on both reactions are the electrons. So you cancel out your 2 electrons on both sides. You're then adding them together. So we have 2I minus plus 2H plus OCl minus yields I2 plus Cl minus plus H2O. This reaction then can move on to our 5th step, which is for basic solutions. So we have 2 H plus ions on our left side of our reaction, so we need to add 2 OH minuses to both sides. Remember, when adding your OH minus and your H plus, you're going to form water. So we're going to get 2H2O plus 2I minus plus OCl minus yields I2. plus Cl minus plus H2O plus 2OH minus. You'll notice that we can simplify because we have water molecules on both sides. So you'll then simplify, or you'll cancel out the one water molecule on the right side with one of the water molecules on the right. So our final answer will be H2O plus 2I minus plus OCl minus yields I2 plus Cl minus plus 2OH minus. And that is your final answer for this example. So let's do a brief overview of everything that we have covered today. So we covered the concept of half reactions. We covered both acidic and basic solutions. A couple things that you need to remember. I highly recommend that you write out each step of the entire process. It is a little tedious. However, if you write out each step and you realize that you made a mistake at the end, you can go back and look at all your work to be able to figure out where exactly you made your mistake. That way you don't have to redo the entire problem. Another one is to not forget about your coefficients. In step 2, there was 4 steps where you're balancing both your elements and your charges. If you forget about your coefficients at that step, you'll completely mess up all the work that follows. Also, double check to ensure that you did each part of step 2 correctly. So there are quite a few steps. There's 4 parts in step 2. Make sure that you get all of those parts correctly. So that is all that we have for half reactions. All I can recommend is that you continuously do practice problems and use Khan Academy. It is a very good resource. Other than that, thank you and have a good day.